So folks, my name is Ritesh Agrawal. Pretty excited to talk to you about Zero Trust microsegmentation and why that is extremely important in the industrial landscape at the moment. Lateral threat movement is the biggest and the most fundamental problem that industry is facing with right now, and we need to find a credible solution to address that problem. Now, the traditional network technically enables lateral threat movement because the way it's built, lots of VPNs, lots of VLANs, all promoting east-west communication, untethered, and that creates the challenge of ransomware or malware propagation, which is what we are seeing. Majority of the industry attacks, if you do reverse engineering on them, will have the component of lateral threat movement where one compromised device, could be an industrial device, could be a VM, could be an IoT device, has the potential to move laterally in terms of threat and compromise as many of the devices that you have in the network. It's a problem that we must solve, and that's what we've started as a journey here at Zscaler as well. Now, Zscaler probably has the most comprehensive lateral threat prevention portfolio, and it's broken down into 4 key pillars as identified in the picture here. I'm going to quickly walk you through all 4 of them and then deep dive into device segmentation today for you. First thing first is we need to ensure that users are segmented from each other. So one compromised user should not have the ability to compromise other users. And the Zscaler ZPA product is specially designed to address this problem. There's also lateral threat movement in your workloads, especially on the cloud or in your large data centers. Need a credible solution to address that problem as well. And Zscaler workload segmentation product is custom designed to address the problem for you. Finally, there are lots of branch offices or distributed organizations that you have that have the ability to connect east-west through a hub and spoke or a mesh architecture. This also has the problem of lateral threat movement because these connectivity is generally performed using VPN technology. We all know how concerning VPNs are with all the breaches that we have seen in the past. So Zscaler Zero Trust SD-WAN solution is custom designed to prevent lateral threat movement between branch offices. This is not your traditional SD-WAN, which for the better part is VPN automation tool. The Zscaler Zero Trust SD-WAN is a modern SD-WAN that eliminates the attack surface by creating an inside-out connection and not using VPN or traditional VPN. And that prevents lateral threat movement as well. And then finally, and the area of focus today for us is Zscaler device segmentation. This is the solution and technology that provides lateral threat prevention or lateral threat movement prevention between devices within the same campus or a branch or a factory or a hospital, thereby complementing the Zscaler portfolio and providing our customer the most comprehensive lateral threat movement prevention solutions. So we'll double click on device segmentation today for this particular session, and we'll get into how it works. But before I get into a lot of details of how it works, let me tell you a little bit of genesis of Zero Trust microsegmentation inside Zscaler now. So the fundamental idea of Zero Trust microsegmentation came from the inspiration of mobile telco technology. Some of you may have thought about it or wondered, why don't we see lateral threat movement on our mobile phones, for example? Let's say one of the Android subscriber ended up downloading a malware. Why don't we see this malware propagate to other subscribers within the same telco environment? The way technology is deployed in the telco is such that it prevents lateral threat movement. In other words, telcos figured out Zero Trust before any of us even knew the term Zero Trust. Relatively speaking, it's a modern stack, and it's a really simple technology. What they do is they put every device in a segment of one or a network of one. And so 2 subscribers cannot communicate with each other than through an application. So it could be a WhatsApp call, or it could be a Slack message, or it could be a Zoom call. That east-west is fine. But the legacy technology like SSH or SMB or WMI or RDP, which is responsible for majority of the cyber threats, is not something what telcos would allow. The exception in the enterprise is that sometimes we have to allow and permit east-west communication for business continuity purposes. And so that's the difference between what telcos have done and what device segmentation has done, which is we provide the exception for lateral communication when it's necessary and required by your business. But for the most part, we eliminate that lateral threat movement. I'll walk you through the details and packet walkthrough at a concept level. There are going to be lots of questions around this, and I'll try to cover as many frequently asked questions as possible in this session as well. So first thing first, you see a picture on the left, which is typical deployment of device segmentation solution. It connects to your core L2 or L3 switch on a trunk port on the side of it. So you continue to keep all your perimeter appliances, your router, switch, firewalls, and their configuration intact for the most part. All you're doing is deploying an additional pair of appliances for high availability sake next to a core L2, L3 switch in each of your organization sites. A site could be a hospital, could be a factory, could be a campus, or could be a branch office, it doesn't matter. All you're doing is deploying device segmentation to the side of the switch. Now, that is the physical deployment. In terms of configuration, all you have to do is shut down the SVI that you have configured on the switch for a VLAN that you want to transition to device segmentation, or you want Zscaler to protect. In other words, let's say you have a factory or a hospital where you have 40 VLANs, just making it up, and you want to start protecting 20 of those day one, and the remaining 20 you will add on 2 weeks from now. All you would do is shut down the SVI for the 20 VLANs that you want to migrate today, and Zscaler will automatically own those SVIs. When the devices send a DHCP request, either it's a renewal or a new request, since Zscaler is sitting on a trunk port and listening to all the L2 traffic, it would intercept that DHCP request as well, and it would act as a proxy. So the DHCP request is relayed to your DHCP server, and a response is then intercepted again, and we modify the net mask to be all ones. So for example, you may have a /24 or /22 net mask. Doesn't matter. As it's traversing a Zscaler segmentation, we would make sure that it is configured as a /32 net mask. Now imagine all your devices are static DHCP devices. They all got a net mask of /32. Their IP address did not change, so your whatever DHCP server was allocating, that remains intact. Their default gateway doesn't change, except Zscaler ends up owning that default gateway. And every device gets a /32 net mask. So if you go back to your networking roots, networking 101, really, when the devices have a /32 net mask, the traffic ends up coming to default gateway. East, west, or north, south doesn't matter. So in the picture there, you see a camera and a robot. If a camera is trying to communicate with the robot, it will have to send the traffic to the device segmentation appliance. And the device segmentation appliance in that scenario is going to inspect and make sure that the camera is allowed to talk to that robot. And if it is, then the traffic is forwarded back to the robot. And if it's not, the traffic is dropped. Everything is logged and recorded so that you can go and troubleshoot in the future or run diagnostics in the future. The beauty of this fundamental architectural difference is that the device segmentation appliance becomes the central point. You get complete visibility and control of all of the communication inside your branch or a campus or a factory in that sense. This is very profound. Like I mentioned, this is proven. Telcos are using it for a number of decades. Cloud builders are using it for a number of decades. All we are doing is bringing this technology to the enterprise, but doing it so elegantly that you don't have to touch the endpoints. You don't have to do piecemeal one endpoint at a time migration. You deploy one pair of Zscaler appliances for high availability sake, and voila, the entire organization or entire campus is essentially configured to be /32 and segmented from then onwards. Now, since we are seeing all of the traffic, east, west, and north, south, we are in the best position to classify these devices. So we do profiling of these devices continuously. And we use nearly half a dozen techniques to classify these devices. And these techniques include MAC OUI lookup, DHCP fingerprinting, DHCP option packets, state machines for various protocols to understand what this device is or could be based on other patterns that we have seen in the wild before. And so these are grouped together. For example, all your cameras are grouped together, all your light bulbs are grouped together, all your laptops or iOS devices or Android devices are grouped together. allowing you to write policies based on those groupings. So you could say, look, I have no reason for Android devices to be communicating with iOS devices. It's a simple policy. You can get more granular. Say, I have no reason for Android devices to communicate with each other over RDP protocol, SMB protocol, or WMI protocol, or Telnet, or FTP, or SSH. We know that's not needed. You don't have 2 employees or 2 guests sitting in your office doing SSH with each other, or employees doing SSH or RDP with each other. These are the reasons we see lateral threat movement. You can prevent these kind of non-necessary protocols that are usually associated with lateral threat movement, and you cut it out. The typical questions that I get from customers are generally related to, what about static IP devices? You explained how this works in a DHCP environment. And so we handle static IP devices gracefully as well. What we do is we give you Active Directory GPO script. It's like a 4 or 5 line script. It's checked into GitHub, actually. Many of our customers have used it to manipulate thousands of their endpoints. There is absolutely no session drop. There is no reboot. There is no restart. There is no downtime necessary as you migrate. Whether they are DHCP or static, it doesn't really matter. As objective as I can be, I have not seen anybody else build something that is so seamless in terms of transition. Ease of use and ease of operation is really important, more so than anything else. And then, of course, the most important thing for us is reliability, and I'll talk about that as well. But let me cover the static IP devices. So we give you the Active Directory GPO script. We also provide Python script and PowerShell script that you can remotely log in and change the net mask. All we are doing is changing the net mask of an endpoint. And that endpoint could be an IoT device, can be an OT device, can be your IT device, or a VM or a container. It doesn't matter to us. We treat everything as an IP address. There are no agents deployed, so we have no visibility inside the IP address, so to speak, or inside the device itself. We are a network-based solution, so that's how we handle it. Now, if there is a device that you cannot manipulate either by using Active Directory GPO script or by leveraging Python or PowerShell script, then we have a way to group all such devices, and we have seen about 1% or less of such devices in a typical network. We would group them into an island, and we will protect the group as a whole from other devices and vice versa. So instead of being micro-segmented in that scenario for that 1% or less devices, it becomes macro-segmented. So it's still holistically grouped together. Let's say you have a class of Canon printers that are 30 years old and that don't have a way to change the net mask, or don't like /32 net mask. In that case, they would become macro-segmented. We'll create a group of all of these printers or Canon printers, and you can prevent lateral threat movement from the group either way. There's always a question about reliability, and reliability is paramount to us because we've been catering to really mission-critical deployments. The original focus for device segmentation was critical infrastructure. We've sold to hospitals where we are protecting ICU patient care units for a number of years now. Customer is extremely happy with the results that we have given, and more importantly, reliability that we have provided to them. And they continue to grow with Zero Trust micro-segmentation. We have manufacturing customers like Kingston and many others that are running factories on Zscaler right now. And uptime and reliability is paramount to them. The way we achieve that is by creating a cluster of appliances. So currently it's 1+1, active and hot standby. And then if active were to, for some reason, not perform or die, the hot standby takes over instantaneously. We use a variation of VRRP protocol between the two appliances. Everybody's familiar with VRRP. And that allows us to monitor the health of each other or two appliances and automatically do the switchover to an active, healthy appliance. Now, God forbid if both of our appliances are down. It's never happened in the last 4.5 years of our journey, but there's always something that is a possibility. And for that, we have built a fail-open architecture. And the way we do that is by using IPSLA monitor if you're using Cisco, or Juniper RPM, and there are many other technologies from other vendors as well. All they have is a way to monitor the two appliances, and for some reason, if they are not functioning, then the SVI can be turned on the switch, and you go back to the state before device segmentation was deployed in that environment. that creates the reliability aspect. There is also the question of performance and scale, because everything is going through the device segmentation appliance here. And what if we overwhelm that device and the device starts to choke? So the idea here is we handle about 80 gigabits per second per pair of device segmentation appliances. These are high availability, like I mentioned before, active and hot standby, but they can handle 80 gigabits per second throughput. And that includes east, west, and north, south. But let's assume that you need 100 gigabits per second for some reason. You can deploy 2 clusters of device segmentation appliances and split your VLANs into 2. So let's say you have 40 VLANs, like I said before. You'd put 20 on one cluster and 20 on another cluster, and you got yourself 160 gigabits per second. The beauty of this solution is it's all routed solution, because every device is in a /32 network. You're getting all the advantages of routing, which is extremely reliable. Most of you are probably listening to this call over the internet. This would not have happened if not for routers. So think of you are sort of converting your switched environment to a routed environment without having to do the heavy lift. We actually handled it for you. And you can enjoy all the benefits that routing give you, namely, the reliability, the scale, the service chaining aspect of it. All of that is possible only because of the routed infrastructure. In terms of latency, some people have the concern that, hey, I'm adding extra hop. It's a router. I'm adding an extra hop into the network. We add about 70 microsecond, not millisecond, 70 microsecond worth of latency to each transaction, which is east-west. North-south probably doesn't matter, but east-west would be additional 70 microseconds of latency. In general, it's good enough for high-frequency trading, so it's good enough for most of the customers I've spoken to. But God forbid you have a particular application that is so sensitive that it needs nanosecond worth of latency confirmation. There is a way to eliminate that. You can keep it in the old school method and still get all the benefits, except for the device that you're not air gapping. It'll again act like an island to us and will protect that island as a whole rather than individual devices within the island. The upgrades and updates are all hitless, much like your iPhone, except iPhone requires a reboot when you're updating. So let's say a new image shows up in your management portal. It'll show you a star sign or a simple sign that says you have a newer version available. And you can choose to upgrade your cluster, and you just hit the upgrade button. What it'll do is it'll first upgrade the standby instance, make sure that health check is complete and it's kosher, and then it'll switch over on the fly. You don't lose sessions, and then upgrade what used to be the active earlier, and then it'll do health check again and then move on. So what used to be your active is now a standby, and what was standby is now an active, but no session loss, no traffic loss per se in your network. So that's a hitless upgrade solution that works seamlessly well for our customers. Now, there is a ransomware kill switch. I want to spend a minute talking about it. This is probably the most potent response to potential impact in your organization. And this was born through feedback from thousands of customers who told me that, hey, why do you have only one set of policies for any of your security appliances? We have a scenario where you need, my organization's threat posture is changing on a daily basis. And it's very hard for us to live with single set of policies. So what we in turn ended up building is 4 sets of policies that you can pre-configure ahead of time. In other words, you can have a policy for normal situation in the environment. You may have a policy for some risk. You may have policy for a little bit higher risk, and you may have a policy for an eventual situation where you know for sure you have a ransomware or a malware impact in your organization. And we color code them. So we'll call them green, yellow, orange, and red policies. You're pre-deciding it. Your auditors are reviewing it. Your team is happy with it. You have done tabletop exercises for these policies, and now they're cemented in the portal. God forbid if you get to a situation where somebody from your team calls you and says, hey, there is a chance we have ransomware in one of our sites, factories, hospitals, corporate offices, and my confidence level in that particular attack is 25% or 30%. We're still investigating. It may take us an hour or 2 or a day to identify really where the threat is coming from. Under those circumstances, it's 30% chance I may want to go to orange set of policies. That may mean shut down access from third party, shut down access to non-mission critical functions like PTO filing or expense reporting, and so on and so forth. And that immediate action allows you to prevent what could have been a catastrophic outcome. And this has happened to a couple of our customers, and they've been extremely pleased with the outcome. What could have been, like I said, catastrophic outcome for them, they identified those devices that actually had ransomware or malware. They were able to eliminate those devices, but the ransomware kill switch saved them. So that's something to keep in mind if you're going to consider a solution like device segmentation from Zscaler. Ransomware kill switch can come in very handy at times when it's crunch time. So at a high level, quick summary, really easy to deploy, no agents whatsoever, can support DHCP and static devices, all kinds of devices, IT, OT, IoT devices. And the end goal is you get lateral threat movement prevention. Your complexity is really reduced. You're able to eliminate your firewalls because you don't need them anymore. Device segmentation is doing that for you, at least east-west firewalls. We have a notion of MAC authentication built into device segmentation. What it means is you don't really need NAC. You can use ZPA or Zscaler Private Access for user authentication, and you can use device segmentation MAC auth for IoT and OT identification, and eliminate the need for NAC really in your environment. And like I said before, since everything is /32, everything is routed, your switch isn't doing much. It's basically, you can turn it into an L2 unmanaged switch, or a patch panel as we call it internally. And that's the goal, is to reduce the complexity and cost of your switching infrastructure, of your firewalls that you have proliferated across the board, and NAC that is extremely complex to manage. So reduce the operational complexity and cost with some of these advantages that I mentioned. And finally, and most importantly probably, is to gain complete visibility of traffic and devices and assets in your organization. Historically, that has been a gap for many of our customers. With device segmentation from Zscaler, you get that benefit. Let's switch gears and talk about some of the key use cases. I have alluded to them earlier as well. So let's start with east-west firewall and access control elimination. I've seen many customers deploy small firewalls all over the place just to prevent lateral threat movement between segments. And that adds additional complexity and overhead of managing, let alone cost associated with these firewalls. You can consider them being eliminated once you have device segmentation deployed within the environment. I also mentioned that we have MAC authentication built in. So with a combination of Zscaler Private Access or an alternative ZTNA solution, you can have user authenticated through some solution like that. But for OT and IoT authentication, we have built-in MAC authentication. So you can eliminate NAC with the combination of the solution. NAC have been historically extremely complex to deploy and manage. And any chance you get to eliminate that is always welcome. And that's what we provide for our customers. The agentless microsegmentation is additional benefits for your critical infrastructure, especially speaking, of course, for corporate offices as well. This is an agentless solution. As I mentioned, it can be easily deployed, and it's one deployment that takes care of the entire environment or entire network, rather than deploying agents or going through manipulating switch ACLs, which are not a scalable option. In my opinion, ACLs were never designed to do segmentation. It's unfortunate that some companies and some vendors are offering ACL manipulating solution. It becomes a troubleshooting nightmare because there is no set state of your network. And when network doesn't have a fixed state, it's extremely difficult to identify and troubleshoot any of the problems that you may have faced. With the device segmentation solution, what you get is a central location where you can see all of your communication. Not only is it good for security, but it's also good for network state management or troubleshooting and diagnostics purposes. And then discovering all of your devices in your network and classifying them, and then providing complete visibility into east-west and north-south communication is something that is extremely important to our customers. They want to be able to see which device is communicating with which device, what kind of devices I have in my network. For example, if somebody were to ask you today, how many Windows 2000 machines you have in your network that are using RDP protocol, East-west or north-south, I don't care. I know RDP is responsible for nearly 47% of the attack surface historically. I need to know that. These Windows 2000 machines are extremely vulnerable to RDP-related attack surface. And how do you know? If you don't know, you obviously don't know how to solve that problem. But with the device segmentation solution, you will be able to get that answer within minutes, if not seconds, and write a policy to say, these are Windows 2000 machines, so I'm not going to allow RDP communication for these machines across my organization. So you can write a global rule, and the rule is pushed into every single appliance of device segmentation to enforce that rule. And of course, you have the ability to override it locally on occasions when it's absolutely necessary for business continuity. But in general, you're able to stop with just one policy, RDP communication blocked east-west, 47% of the attack surface, and can be argued whether it's 40 or 50%, but let's go with 47% for now. And so that's the magic and power of device segmentation from Zscaler that allows you to prevent lateral threat movement and create those exceptions easily. So in terms of, double-clicking on the east-west firewall replacement, like I mentioned, in this case, you have two sections shown as IoT devices and servers. Traditionally, you would have put a specific firewall between these two segments. Now, with device segmentation, you don't need to. Not only that, we will be able to protect lateral communication between one segment and to the other segment, it would go down below to individual devices or IP addresses, where you can optionally extend the policy to do microsegmentation rather than just the firewall replacement. Just to extend the thought, the IT/OT segmentation, this becomes critical, especially in healthcare and manufacturing, where you have a lot of vintage operating systems. Some of these devices could be 20, 30 years old. Let's say an MRI machine that could be 20 years old. It's working. It happens to run Windows 95, but nobody's going to throw a $3 million machine down the drain because Microsoft decided to move on from Windows 95. As a matter of fact, the latest medical device that you can buy from many, if not all of the manufacturer runs Windows 2007 operating system. By nature, 2007 is already outdated. So you could go and write a check for $3 million to get the brand new MRI machine, and it'd still be outdated. So these vintage operating system creates the attack surface for you. Having microsegmentation without having to install agents is really the right way going forward, and that's what device segmentation enables for you. We talked about NAC replacement or NAC agent replacement. We talked about east-west firewall replacement. And then, of course, being able to get microsegmentation is cherry on the top for you. And then visibility. And we really go deep into this. On the left-hand side, this is a screenshot from one of our demo environments. On the left-hand side, you're seeing device classification by operating system, by manufacturer, by automation, by network type, and so on and so forth. These are customizable. You can go on the chart on the top right, a pencil icon shows up as soon as you hover a mouse over it. And then you can edit these charts, so you can change it to your needs. You can change the chart type, colors, and so on and so forth. And what is more exciting is on the right-hand side, you're seeing all of the communication patterns within a particular network or between different networks. For example, if somebody told you that my industrial printer was not working yesterday, what are you going to do about it? You can go and in the search window on the top right, you can put in the MAC address, host name, or tag. You can create custom tags. You can write your own tags. You can put that tag information, and that device becomes the center of universe, and you see all these arrows in and out of that device. And these arrows have particular meaning to it. A red arrow means there is a specific drop policy that we are executing. So you click on that arrow, the policy shows up at the bottom. So you know exactly which policy is dropping this packet. Green is the opposite. There is a specific allow policy that is allowing that communication. And when you click on the arrow, it'll show you the policy at the bottom. And then black is the default policy. So your default may be deny all, maybe allow all, whatever you like. And you know that it's taking a default policy, so I don't have a particular rule for this particular transaction. And you may go ahead and write a rule or override a rule, depending on your volition. But the idea is to be able to diagnose and troubleshoot any problems that you may be facing in your networking environment, and that's the easiest way to do it. We typically store every packet header inside your organization. It doesn't matter whether it's east, west, or north, south, whether it's light bulb talking to camera or camera talking to a printer, it doesn't matter. We will store every one of those packet header by default for 7 days and on request for extended period. So you can go back in time and look at historical communication pattern to and from any device or all devices for that matter. I'll talk about a couple of customer case studies. There's a lot more to it, but let's focus on a couple of them. Flex, which is the second largest ODM in the world, is now deployed Zscaler device segmentation. They have deployed Zscaler device segmentation in 48 of their 70 factories. The same technology I described earlier has been deployed in Flex for more than 3 years now. July of 2021 is when they first onboarded their first factory in Austria. Their challenge was they tried every solution, the NAC-based solutions, the ACL-based solutions, the agent-based solutions, and everything under the sun, and it just didn't work. And it was obvious to me that it won't because I've dabbled with some of these technologies in the past as well. Once they looked at Zscaler device segmentation, they understood the value proposition. Obviously, it scales, like we mentioned before. It solves all their problems. These factories are mission critical. This is revenue uptime, sometimes even related to potential impact on workers' health and safety. Uptime is really, really important to all of our customers, especially Flex, because it's tied to not only the revenue uptime, but also worker safety and health at many times. So they were extremely sensitive about uptime, and we made sure that that's the case, and they're extremely happy. Hence, they went from 1 factory to now 48 factories, and we are on our way to get all of their 70 factories. 30% reduction in downtime, about 100 tickets per year per plant were reduced. Now, if you do the math across 70 plants, that could be up to 7,000 tickets per year. You can do the math. It's extremely important for them. And then they were able to save cost because all the other technology they were using that were not really helping them is gone. And so it's cost saving, firewalls replacement, and all the other benefits that I talked about. The end result is every IP is segmented within the Flex production environment, and they're able to write special exclusions whenever necessary. I'll talk about another case study. This is a very different customer, Tilly's. Many of you have probably seen their stores in malls. They are distributed across 33 states and 250 stores roughly. Every single endpoint in Tilly's, their corporate office, there is warehouses, their data centers, everything is protected with device segmentation. And their challenge was lack of visibility and potential ability for bad actors to move laterally. And they wanted to prevent that from happening as soon as possible. So this was the fastest sale we had, such a meeting of minds. We met them on day 1. Day 3, we had a PO in our inbox. And day 7, Zscaler device segmentation was fully deployed across the board, across all their networks, and they continue to grow. They not only bought the segmentation solution, but they also bought additional capabilities and features that we delivered from Zscaler. So that brings me towards the end of my presentation. A couple of quick action items. If you're interested to learn more, or if you have more questions about Zscaler device segmentation that I was not able to answer today, happy to do a deep dive architectural workshop with you. Please initiate a conversation with your sales organization or reach out to us through our website. And happy to talk to your technical team, bring them on board, give them a deep dive details on how device segmentation works within your environment. So thank you for your time and the opportunity, and I look forward to collaborating with you in the near future.